Good afternoon, Robert Scribbler. It is August 31st, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I am going to talk about the extraordinary rainfall totals that we have seen in Wisconsin that have really hammered southern and western parts of the state, producing numerous instances of flooded roads, flooded streets, in some cases flooded homes, numerous water rescues. In Madison, for example, wells have been contaminated with bacteria due to flooding. Apparently 20% of all wells have been contaminated. And the list, as we can see in this Wisconsin State Journal newsfeed, just goes on, with emergencies declared in numerous locations for western Wisconsin and record river levels being produced in some locations. Now, what I'm going to do is I'm going to talk about the overall context of the situation and talk about a couple of climate change fingerprints on this heavy rainfall event. So overall, it's worth noting that between 5 and 15 inches of rain have fallen over parts of Wisconsin over the past week. So this analysis provided by NOAA and weather.gov showing very heavy rainfall in the north central portion of the United States, particularly centering on Wisconsin. And I'm going to talk about some of the causes, but I just want to note that atmospheric moisture levels over the eastern part of the U.S. have been very high, and a shift in the jet stream has tended to trigger more storms as troughs have moved into the west and central U.S. with a strong jet running up through the north central U.S., tapping into high moisture loading and high heat in the southeast, as well as instability running in from the north. So National Weather Service in Milwaukee notes that 2-week rainfall totals have been even more intense for Wisconsin, and unfortunately the next 10 days look pretty active as well. And I'm going to show you a predicted 5 to 7 day rainfall total provided by NOAA QPC, which is a model that forecasts precipitation totals, showing another 5 to potentially as high as 10 inches or more of rain for parts of western Wisconsin, as well as running into Minnesota, Iowa, and parts of Nebraska. So very heavy rainfall continues to be predicted in this region due to prevailing weather conditions. Now, I'd just like to talk about some climate and weather related and climate change related signals for this event. And it's worth noting that sea surface temperatures in the Gulf of Mexico, off the southeast coast, and particularly off the northeast, have been higher than average to rather higher than average to much higher than average. And all of these very warm sea surface temperatures, these warmer than normal sea surface temperatures, have tended to dump a lot of moisture into the atmosphere. So I want to show you surface wind patterns. So what we have right now is a high pressure system off the U.S. East Coast, which is circulating air into the U.S. eastern section and central section as the high pressure circulates in a clockwise fashion, pulling in that very moist air from warmer than normal to much warmer than normal sea surfaces into the eastern and central U.S. And you can see these high moisture readings running up through the Gulf states, very high moisture down in Louisiana, very high atmospheric moisture running in through Kentucky and Tennessee, as well as in through parts of the Northeast. But note the plume moving up through the central U.S. and stretching well into the Hudson Bay region of Canada. This moisture plume taps tropical moisture levels and is running into conflict with trough patterns that have been dipping in through the central U.S., firing off very powerful thunderstorms. Let me go ahead and show the upper level wind patterns, and hopefully this will load. There we go. So note a trough presently dipping in through northwestern Canada and providing a lot of upper level energy, a lot of upper level winds to provide energy to tap that moisture and generally kick off thunderstorm development by adding a good degree of instability in this region that has already been hit by heavy rainfall. So just to note as a general context, the high atmospheric moisture levels that we are seeing are a signature of human-caused climate change in that as the Earth warms, you tend to get more evaporation, which pumps more moisture in the atmosphere, and so the hydrological cycle amps up a bit. You have a higher water vapor loading in the Earth's atmosphere, and because this water vapor isn't spread evenly over the Earth, it tends to concentrate in certain zones based on weather patterns and prevailing weather patterns. This can tend to increase the peak potential intensity of rainfall events. In the U.S. East and Southeast this year, we've seen much warmer to warmer than normal sea surfaces, a prevailing pattern that has pumped a lot of moisture into the eastern and central U.S. And this feature has a fingerprint of human-caused climate change on it. Now, in addition, we've tended to see a rather wavy jet stream pattern over the U.S., and there are a number of scientific studies that have indicated that reductions in sea ice in the Arctic have a tendency to generate more ridge and trough patterns during northern hemisphere summer, which can also amplify extreme weather events. So just a chat about the general larger term trend when it comes to climate change as it relates to the extreme weather that Wisconsin is now seeing. So thank you for joining me, and I'll be chatting with you soon.